Hello everyone. Today I continue solving problems on the Leetcode. Let's show you where I am. Yesterday I solved the tries topic. It was hard. I didn't solve it by myself, but uh, mm, I I I learned this type of this technique, and I'm going to solve it again later, but not now, but later. I'm going to come back to this task, to task which I solved yesterday, and solve it again in future. Today I will solve backtracking topic. I already learned about it. I already researched which examples of solving, and I'm going to solve problem. And I learn this technique before to spend less time on the video. Backtracking. Let's try to find it. Backtracking. Here is. I have solved 0. Whoa. Is there any easy problem? No? Easy. We have easy 1, 2, 3 problems. Okay, binary 3 paths. Binary tree paths. Given the root of binary tree, return. So, given the root of binary tree, return all root to leaf paths in any order. All root to leaf. Okay, I see. A leaf is a node with no children. And we have an example 1, 2, 5 and 1, 3. We need to return. How I need to return the result? Let's watch test cases. What test expect from my solution? Wow, it is Kotlin. I need JavaScript. It expects merged as strings results. Okay. Well, let's overview solution, this technique again. So backtracking algorithm are like problem solving strategies that help explore different options to find the best solution. They work by trying out different paths, and if one doesn't work, they backtrack and try another until they find the right one. It's like solving a puzzle by testing different pieces until they fit together perfectly. The main is undo option if they lead to dead end. So I don't know how can I use this approach here, because an example wasn't is not similar to example which I how to say it, ознакомился, got acquainted.
Got acquainted.
Okay, is not the example I got acquainted. So example is print all subsets of a given set of or array. So we have an array 1 to 3, and we need to return all subsets starting from empty. Some subsets. Empty 1, 1, 2, 1, 2, 3, 1, 3, 2, 2, 3, and 3. And it has the picture here, but actually I didn't understand it from the picture, but I went to the code and I got it. I think maybe here we have, no, it's an illustration. I thought maybe it has another example or approach. Iterate numbers from 0. Yes, it's all subsets by using bit manipulation. I believe it's not the time to using bit manipulation approaches. I will learn it later. So in current task, I think it is not hard to use this example. So we have a result array, source, collection of items, and we call our method which has current subset, result of subsets, and current index. And then we call the recursive function which will calculate as all of the subsets. Let's apply this approach to our problem. So what we have, var result not subsets, get paths, root, from the root, return result. How can I I would like to join the not join map result map all and join result to strings after getting all paths, because I'm going to get result in this format, like 1 2 5 5 1 3. So I need to make something like that. Path join yes. Var get all paths function 3 var result paths var I'm just copying this approach. Index is 0. I don't need index with when I work with 3. I just need to write a recursive method function which will calculate calculate paths for me, starting from current tree I need to remember previous tree to return to it, because if I will not, then stop, no, I don't need to return back, because I just need to iterate through tree and write the current and write the current path until I reach the leaf. When I reach the leaf, I just push the current path to the result and stop and exit from recursion. So calc is function node is let's say paths if no node no, if node left, I just no, I need to push result to the current path to result if I reach it to the end or not. No, sorry, if node left calc paths, then I need to calc paths with node left path push node val and paths. If I don't have left and right but only value, then I need to return the result, or I can make or just one comparison if no node. Yes, if not node, then path push path else, or not else, just exit from recursion and calc paths, calc paths node left path push node val and create new path paths node left, node right. And this is not correct, because I will push the same path 2 times if it is the end of the leaf. I see it right now. So how can I need to work? Let's write something. Let's write it. So I have some tree. Something like that. Then well, where is my solution? Initially I call it on the tree. Maybe I need to check the value in the tree before. And push it to the current path. No, current path should be empty when I make initial invoke when I initially invoke the recursive method. Yes, I call it on my root item. It is 1. So I have a 1. This doesn't work. And if I make it like that, it will push it. No, it is not correct. Aha, I need to create the new path only when I have left or right subtree. Okay, let's rewrite it. If node left, then I push current value to path, node value, and recursively call our method on node left, new path and paths. Else if node right. This almost same. But for right subtree. Create new path. But I can't push it 2 times. If I don't have no, because the initial tree can be empty. So I just need to return. And our paths will be empty, but we have one. I need to push it to paths. Empty path to result. Okay. Well, when I have when we have something, then we need to push the current value to path and continue on the left or right subtree until we stop. How can we stop? If we don't have node left and don't have node right, I need to path makes similar thing. Path, push, path, and return. Looks like this should work. Path and paths. Where result? Aha, I didn't return the result. Paths. Let's watch, let's try. What is this? I miss something. How I miss the second subtree. Let's investigate. In second case, it's everything is okay. So we have a tree, we have an empty path and empty paths. All right. For the root node, this comparison will be skipped. Then we push to the path current value 1, and we check if it don't have. Aha, I see. If it don't have node left or node right, then we return, but we don't need to return because it should be like that, because if we return after traversing the left subtree, this method will be returned and the right side won't continue or not. I don't know. If we have node, then we have value. So I think I can we push. I don't know. Let's just try it. The same result. With premium I can use debugger. Didn't know about it. Let's try to clarify how it works. So we have the node, we have the left and right subtree. It will be skipped. The path is empty. Current path is empty. It has the 1. So we invoke it for our left subtree with the new paths array. path array. Okay. The left subtree working okay, but for the right subtree it doesn't work. Why? Let's try to console log. I don't understand. So if we have the left subtree, we calculate for the left subtree. If we have the right subtree, we calculate it for the right subtree. If we don't have any, we push it to the push it to the result. We exit from recursion and return the result. Where is the mistake? Let's try to write it a bit different. Let's try to simplify it. So if we have left subtree, calculate for the left. Aha, we need to calculate. Aha, I see. I calculated only one time. If node left, I calculated, and other things didn't calculate it. Okay, so in this case I need to make it like that. If no path, node left, node right, then push it to the result. Something like that. Probably it should work. Why? Now I have extra path. And I need to return it here. Push current path. No, I think it is still is not correct. 1213, but exited from left subtree. It didn't continue to the right subtree. Interesting. Let's watch example again. Result push subset. I calc subset for a result subset and index initial result here, which will be, no, it is whole result initial subset. Aha, I watched this solution and took it as an example, but I need to adjust my solution because this is for all subsets of the tree. So we need to get all results of this subtree, but in my case I need to take only finished subsets. No, I need to take only result only if push result only when I when only when I reach the leaf, when I reach the leaf, and when I reach the leaf when the node doesn't have both of subtrees. Let's watch my solution. I push it only looks like it's okay, but something is not okay. I need to adjust it somehow. So let's move this check outside because it doesn't we don't need it. Or maybe I need to use it. What if I will go to the left and right subtree anyway and use this thing? How? I don't know yet. If I don't have node, I return result. No, it doesn't work. Only when I have this one, this check is okay. If my node doesn't have, if the current node doesn't have both left and right subtrees, sorry, I have misspelled here. Wow, now it works. Wow, the algorithm was right, but it was misspelled here. Well, let's try to submit it. Whoa, runtime beats 99% of users with JavaScript. I took a lot of memory. I know it's okay for me. I'm not confused by it. I'm not frustrated. I like that my solution is so fast. I think it's fast, although I used additional calculations. I make on square here because no, or yes, because we go through the result in the end, and for every A8 item we went through all of sub items. Maybe I can adjust it by using by not using arrays but using strings as paths. Then I don't need to make this map and joins. Okay, here our current path will be string, path is string. We push our current path to yes, paths, it's okay, but here I don't push it. I will I will join strings here, path, delimiter and node val, and this is the same for both. I don't need this one. Looks like it should work. Oh, I missed the initial. No, I missed something. Here I need to push this path. And here I have some extra connection. Well, initial path is empty, so I don't need to use connection. It is additional calculation. I don't want to do it. How can I avoid it? It's additional comparison. How can I avoid it? Okay, let's try do not avoid it, but just use it path, then use delimiter, or if no, we just use empty string. It should be accepted. No, why? There is no path. It's var updated path updated path updated path. And let's compare statistics. What will we get? Oh my god. I don't save any memory, maybe a little bit, but I reduced I got significantly reduced runtime. Let's try it just to be clear, just to check. Let's try to submit again. Oh my god. But I saved some memory. How can I avoid of using I can avoid it by moving this comparison out of recursion. So if not 3, return this one. And path will be 3 value. So then I don't need this comparison. This comparison I don't need to compare it for is my current path empty or not. Even more, I don't need to push updated path, I just can push current path, and only here I send updated path. Let's check it. Wrong answer. 1 1 2. I have I need to push node left value and node right value, because I have right and left node here. Expected string, but I got how can I make string from it? I even don't need additional variable for it. I just can I don't remember which way JS how to cast number to string best way. Some examples. Answer concatenate it with empty string. To string is faster. Let's use toString. Let's submit it. I don't have any additional. Why I have so slow runtime and memory. I have result. I can reduce memory by removing this function, because I actually don't need it in my case. Let's rename something. Result path, and here I need to pass result. Let's try to submit it again. Tree is not defined. Everything is a root. Sorry, what I have broken. If I don't have tree, I just return empty array with one path. Result empty array. Why it is empty? Is it working? It works. Oh my god, why I have so slow memory? Okay, anyway, it's great that I managed to solve it. I think I didn't understand backtracking method clearly, because how to say it, I didn't backtrack anything in this solution, even in example which I even in example which I got acquainted doesn't have don't use backtracking, actual backtracking, because it's something like just go to the end without backtracking. Maybe I don't understand it yet. Let's watch other people's solutions. Beats, okay, we don't care. What have you done? Result DFS. You just go through whole tree not node return, if path plus string node current value, you merge it with current value, else you you create a new string with path, okay, with initial path. If it is a root node. Okay, if you don't have two roots, you append path to result and return, and go out of recursion. Otherwise, you do it for the left and right nodes. I have one idea in JS how to merge strings. Maybe there is some faster way to concatenate. Are there any calculations? Stack abuse plus concat or concate, how to
Concat.
Okay, concat. It can be invoked over any string and accept another string to be concatenated to the calling one. It's similar using the shorthand operator. String concat string 2. Which approach to use? Performance benefits. Okay. Concatenating with operator with function. And run this on different machine. It has the same time. On the MDN, worth noting the official statement from MDN regarding the performance benefits are used instead of concat methods. Which might seem odd given the fact that concat outperforms the operators in the tests, or at worst is the same speed. What gives? Well, benchmarking code like this isn't as easy as simply running it and observing the results. Your browser, its version, as well as the optimizer it uses may vary from machine to machine, and properties like those really impact the performance. Okay, let's just try both approaches. Let's just use operator plus operator first and the next. And after it I will try concat operator. Aha, probably I can save some memory. Extracting our delimiter to variable. Let's submit it and let's watch what we will get. I have reduced runtime. Let's try to concat. Concat. Also, I need to concat. I need to cast, recast this value to string, like that. Let's check is it working or not. Yes, and try to submit it. It's good. It is good. I like it. We have runtime as well as memory. Also, I think I can. No, I don't use it. Let's try to remove. Remove it and submit it like that. Aha, I saved some memory. Let's convert it to string like that. As I see, it differs a lot from one to another run. Yes. Okay, I will left it like that. I just want to own solution. Interesting. In build stack for recursive calls. Solve root. Solve is recursive. V. What is V? Where is the V? I don't see. V is the field in class. So we make solve root s. Initial s is empty if no root. Blah blah, return else. Push stack s. If you have no, you make some similar on, we have n and nodes in tree, and you watch every node one time. It is the same result, but with additional checks. Nothing new. Backtracking, Python, DFS, if not root return, if not root left, root right, result append current value. All we have similar solutions, every one of us. Okay. Let's watch maybe couple of additional backtracking methods. Backtrack, root, empty. What is this? Node left, node right, path append current value, res append, result append, join path. Okay, it is current path, it is result. It is the same. It is enough, I think, because everyone implemented the similar solution. So thank you everyone who watched me, and bye. This is all for today.